Here I am again. A-level chemistry. Would you believe it? Haven't taught this in a while. But it's been requested. So I'm just gonna briefly take you through the kind of things that are likely to come up. This isn't a tutorial video by any means. Of course, I'll just point you in the right direction for certain things, but that's not my intention to go through the questions. Alright, so let's look at breadth in chemistry. This was last year's paper, so what's what we got? You're definitely going to get an electron configuration question. They like that. 100% you'll get that. It's like in the first section, definitely you're going to get that. They especially like to play around with you when you get to the d orbitals, so don't mess around there. Do know that. Yeah. Alright, so what is the number of element X? Yeah, this is a beautiful question. So here you've got to, obviously you know that the number of electrons is in total is the same as adding all of these up. 2 plus 2 plus 6 plus 2 plus 4. That gives you what? 4, 10, 12. 12 plus 4 is 16. Why did I just say that? Because it's true. 12 plus 4 is 16. Okay, so what has 16? 16 is 16. What has 16? That is it. Oxygen. Oxygen has a mass of 16, so it can't be oxygen. I'm just trying to think. I've got right here. I should have a data sheet. Sorry, I don't know this off the top of my head. It's been a long day. Sulfur. Okay. Sulfur. So now you know it's Na, and that one's going to be sulfur. You've got to figure out, okay, what's the compound? How's that going to work? Well, sulfur is in group 6. So what does that mean? In order to balance out for Na, we've got to make sure that there are 2 NAs for every sulfur. So it should be Na2S. What question is that? Let's see. Yeah. So Na2S, so that's our answer. So that's a double question there. So really, that the first part of that question is quite easy, and then the second part, is kind of an introductory question. This kind of question is basically knowledge, being able to manipulate knowledge, not just straightforward stuff. It's the same as this question, to be honest. What's the number of oxygen atoms in 88 grams of CO2? What's the atomic mass. Sorry, relative molecular mass of CO2. That's 12 plus 16 plus 16, which is 44. What's 44 is half of 88. Okay, so working with that, how many molecules of CO2 would there be in 88? Sorry, how many molecules of oxygen? There'd be 4 molecules of oxygen in 88, but that's if we're dealing with atomic mass units. We're dealing with grams here, so what do we need to do? We need to multiply that by 6.02 times 10 to the power 23. So let's do that. 6.02 times 10 to the power of 23, and then multiply that by 4. Gives us 2.41 times 10 to the power of 24. And that also is our answer. Okay, so you got to know, how to do your calculations, standard calculations, in chemistry. This is, this one I do have some videos on. This particular one on volume of gases is one of my very, very earliest videos. It's about an hour long, and it's me sitting in front of my computer going through some questions. It does actually have chapters in the description, so you don't need to look through the whole thing, but yeah, just know how to do that, because those are easy marks if you know how to do them. And you got your oxidation numbers here. These questions are the solid gold, because they're just gold if you can do it. As you know, transition metals have various oxidation states, but they're just certain things that simply don't change. And you've got your oxygen there, which is going to be -2. 4 times -2 would take you to -8. Then you got your group 1 metal, so that is always going to be +1. So if you're in -8 and then you've got 2 +1s, that would take you to -6. And this thing has got to be neutral. You've got to make it 0. So how am I going to make this 6? You're going to add 6 to it, so it's going to be +6. And so that's going to be your answer for the oxidation state of Fe. Let's have a look. That's what I'm talking about. So, what else? As I said, I'm not going to go through this whole thing. So, you got to know your... this is another simple question. A nice one. Don't get these wrong. Don't get any simple ones wrong. This is the number of protons in a nucleus. Very, very easy. Do not get those ones wrong. Ionization energies. Once you get the hang of it, then it will come a bit more simple. It becomes a bit more simple. So think about what's happening as you're knocking off those electrons. What do you expect will happen? Thinking about the electron configuration. Then you've got your standard dipole-dipole interactions. Key there is the word induced. Okay, what else? This one, enthalpy changes. Enthalpy changes will come up. Know how to do them. There are various ways of doing it. I can't remember if I've put a video up on it. No, I don't believe I have, but I do actually have various revision notes on it, where I've actually gone through this thoroughly. You'd be able to find this on the TES website, Teachers Educational Supplement, under resources. If you look up my store, or you type in NASA Fellow, maybe you'll find it. There's a question, there's a lesson, it's called like a shop called Interview Lessons. What I'll do is I'll make it free so that you can download the resource. But that is like I went through in detail, carried out some notes there, methods on how to do it. What else? Errors. This is quite an interesting one because it's kind of looking at practical techniques as well. Reversible reactions. This is Le Chatelier's principle, isn't it? So here you're looking at, it says what would shift the equilibrium position towards the product. There's your product. What would shift it that way? So you know that reaction is exothermic. So exothermic obviously releases heat to the environment, releases energy to the environment. And you've got to take that into account, your pressure as well. You've got to think about, rather than having two sets of molecules, you want one set of molecules. So you've got to increase the pressure as well to push it over there. Now, if you increase the temperature, then what you're going to do there is you're going to allow the energy to, just trying to think, I think you're going to allow the energy to actually be used. Hang on a second, let's see, what question is that? Is that D? No, it's 13. Question 13. Question 13 is C. So by decreasing the temperature, what will happen is it will shift the equilibrium to trying to increase the temperature again. Thus giving off more energy to the surroundings, which makes sense. Because if you had an endothermic reaction, what it would do is it would use up that energy. If you increased the temperature. So yeah, that makes sense. Sorry, my mind's working a bit slow, I apologise. It's way too late to be doing this video at, you can see the time there. Alright, so what else? You've got these standard mole calculations. Again, I've done a video on that, similar videos on that, so you can have a look at that. How many structural isomers are tertiary alcohols of this are tertiary alcohols? Draw it out. Just draw it out and you'll see it. This one is another beautiful question. Don't forget, when you're doing this, each carbon can only have a maximum of four bonds. So here, if you've got 1, 2, 3, 4, that one can't have a hydrogen attached to it. That's 1, 2, 3, 4. That one can't have a hydrogen attached to it. What are you going to have there? You're going to have one additional hydrogen. Here you're going to have one additional hydrogen as well. This one additional hydrogen, this one as well. And it kind of works its way around. Then you'd know that this is a carbon, that's a carbon. That's an easy question. And then here you've just got to know all the standard stuff about what is going to be produced depending upon whether things are primary, secondary, tertiary. What I have done for my old class at Drayton Manors, I did actually keep the PowerPoints up, so you should be able to find the links to the PowerPoints in a Google Classroom still. I'll see if I can stick that in the description of the video as well. EZ molecules, know that the mass spectrum, that's going to come up, but they might actually move that one to section B. Okay, so from section B, this is where the real deal starts. So they're always going to start you off with something nice. That's like a GCSE question, where they ask you the protons, neutrons, and electrons of something. And then they start getting serious. Then you've got your dot and cross diagrams. So again, you've still got some simple ones, but then afterwards you've got to know the shape, and then explain how, why the shape is. Sometimes they give you a random molecule, phosgene. I mean, what the flip is phosgene? You have never seen something like that before, but when you see the shape, you should be able to describe it as whatever it is, based on the fact of, what have you got, how many you know, how many bonds? What's happening there in terms of bonds? How many electrons have you got? Have you got anything to do with, you know? Have you got anything to do with lone pair? Why does it look like that? That one is, you can see, is a that one I believe is a trigonal planar shape. Why is it like that? You've got your bond. They might ask you the bond angles even. That'd be 120 degrees all the way around, isn't it? Where is that? Is that 1B? That's if they ask you the bond angles. Yeah, see, trigonal planar. They did it as it is. So in your exam board, you can actually just get away with saying allow three bonded pairs. That's good. Or you could, but then you have to also say, obviously, that there's an electron pair bond repelling between them as well. They move as far as possible. Those ones. So know your shapes of molecules and know why. Know why certain things have. What is it? Know why if you get something with a lone pair, you'd get extra. You'd have to leave extra room. Again, this is the same kind of question as before. These are electron configuration questions. Here we are. You've got your standard redox questions. And what's this? This is one of those titration questions, isn't it? No, not titration. But it's those kind of reacting masses questions. And I do have a video of that up on this channel, so I'm not going to go through that. Please do familiarize yourself with that. How could the student obtain a mass of potassium phosphate after? Yep. So again, what's this? Some more preparation questions. This one. Calculate the volume of phosphate gas formed. So, you see these ones, this is a 4-mark question. So, this one is going to involve a few steps. It seems quite similar to the steps you'd take in reacting masses. But you're gonna have to take a few steps first. Try it. That's what I say. Try the question. Like, what is this? This is 22. 22B. So this is one of these. This is a PVNRT question. So it looks even there that I told you there's involvement there as well. So in multiple steps, it looks like you've got to make some conversions there. Look at that. Sorry. Kilopascals, 200 degrees C. Surely you could get away with completing this question without even all of that, like conversions and stuff. I think that with the if you I'm gonna be cheeky here and say that you do need to actually, because I'm thinking, I remember now, with PV equals nRT, you do need to have it in Kelvin. I forgot. Last time I did this properly, I was doing my AS levels, so you do need to have that, yeah. Make those conversions, but yeah, sure, even rearranging that gas equation, give you an answer, give you a mark. Just try it. Look at this. Energy changes and rate of reaction. Okay, so again, if you're going to do this kind of question, I do have some revision notes on it, but if you've got your own revision notes on it, even better, because what I found is by sitting down in front and practicing, it all made sense to me. So I'd recommend you do the same thing. But yeah, maybe I should include, I'll include the link in the description to that resource where I actually literally go through it every bit at the end of the experiment. So yeah, this is a bit of experiment stuff as well. So that's breadth of chemistry. It's like that, to be honest. This paper is the most unpredictable when it comes to breadth. They test everything. Right, look at that. They test everything. Then you've got your saturated hydrocarbons here. What's the name? Structural isomers. Yeah, they did this on purpose. This is not how it used to be. They're testing everything. So I mean, like, the hard thing is, I can't really, for this first paper, I can't really sit down and say, you know what, this is likely to come up, that's likely to come up, because breadth of chemistry is designed against and to play against those predictions. know your mechanisms and structural isomers, be able to determine that. Now to draw these possible ones as well. And the different mechanisms. I used to absolutely love teaching this and get so excited when my students would get these right. Just literally have a molecule on the board and I'd say, alright, how do you get to this? How do you get from this to this? How do you get from this to this? Let's turn this into this. What do we do? And we're trying to fill in the steps and try and make this big map. That's what I got my students to do. Get this big map. Make a big map of turning what molecule into what molecule, and like literally every single type of reaction. I know it's going to be huge and I know it's lengthy, but it's, it's worth it because you do need to know what's going on there. Okay, if you distill it, what's the difference between if you distill it and then if you reflux it, what's going to happen there? In terms of the what's going to turn into a ketone, oxidation, carboxylic acid, what's going to happen, what's really going to happen there. Then you've got your mechanisms, drawing mechanism. Please remember to draw your mechanisms right. Be careful with your curly arrows. The spectroscopy. If there's one question, there's one type of question I hate, it's spectroscopy. But they can actually be quite easy if you just spend some time sitting down and labeling it, because you can see certain spikes and you match these up with your data sheet. What's in your data sheet? So you're matching up with your data sheet and you kind of see what absorptions are happening where. Look at what's going on. And then you match it up to your data sheet and you can actually predict what molecules you're actually going to have. So yeah, that's that one. Sorry, it's very, very brief and not in very much depth. I'm sorry about that one, but yeah, there's breadth in chemistry. Let's have a look. There must be something else as well. Another paper, breadth in chemistry that we can actually look at. Maybe have they put another one up? Let's see. So that was 2018. It's 2017. This was the specimen paper, obviously, because there wasn't exam back then. For back then. So how many electrons on this? You see, this, my opinion, when I look at this paper, the specimen paper looked a lot easier than the actual one. Look at that, there's a lot of calculations you got to do. But in a way, you know, some people might say, oh, actually, you know what, the real one turned out to be a bit easier because you didn't have to do as many you didn't have to do so many equations. Because one of the things here is you have to do so much to get 1 mark. And you think to yourself, is it worth the time doing that to get that 1 mark, or can I invest my time somewhere else? And I think that you ought to balance that when you're having a look at your paper. So, you know, the specimen paper, arguably, even though it had more calculations, quite similar things, I would say that maybe you'd have had to work less hard to get. You'd have to work more hard to get the same amount of marks. It's just an observation I'm making. It's obviously all subjective. There's some easy ones here, there's some hard ones there. That's just how it is. Try and get as many questions right in section A as possible. Look at that, there's another error question there. So you know you know that there's going to be an error question there. If error question came up in the specimen one that came up last year, we can expect it to come up again. But notice how there was only 1, so there'd be no more than 1 there, and it's likely to be a 1 mark question. Full electron configuration. Look, that came up again. And that's a 1 mark question, but I'm sure we might have actually got even another one earlier. Was there another one? Doesn't even look like it, to be honest. But still know it. You might get two questions there. Definitely, if you're doing the other paper, you're doing a retake, you're gonna get that question asked again. Especially when it comes to the synoptic paper. So just know what's going on. What does that mean? Look at your observations. What does that mean in terms of reactivity? What's going on? Know what the skeletal formula is. Don't draw out the blooming, what is it? Shape. You need to make sure that you know what's what. Explain why this type of mechanism is likely to produce a mixture of organic products. So, know about racemic mixtures. Know about what's likely to produce multiple isomers. This one is standard question is catalyst. You got to state the catalyst used for that. Hydration of ethene. That's one of those reactions where you just simply got to have your, that big map I told you to draw out. Just have one of those, and it's definitely an easy one to get a mark for. Atom economics. This is a word question. Sometimes you get these wordy questions at the end, In the actual paper, they gave you a wordy question. What was it? They want you to, look at that. That's a 5-mark question. That's a long question. So there is a wordy question that you have to say, but generally the questions are all quite 2-mark, 3-mark questions. 4-mark question for that one. Boltzmann distribution model. Know what's going on there, because otherwise you're gonna be screwed over. What I would say is very, very difficult, if not impossible, to predict what's coming up in breadth, because what they like to do is, if they're not gonna cover it in depth, they're gonna cover it in breadth. As usually just like a skimming the surface kind of thing. Anyway, that's the paper ones. I can't. That's the paper one for breadth. So let's let me have a look at. Let's have a look at a depth paper. Let's have a look at a depth paper.